Hello dear students, I am Mr.Ismail, a physics teacher at Typical English School. Today I will solve some new or some mini-strong question for you. The question of today is about chapter 2. This question is about of the year 2025 first round. Dear students, at the beginning I will solve question 1. Chapter 2 is about of equilibrium and rotational motion. Okay. Chapter 1, or question 1, sorry. If the torque required to loosen a nut of the wheel, okay, of a car has magnitude of 50 Newton/meter. 50 Newton/meter. It's very important. This amount of what? Of torque. Okay. What minimum force must be exerted, okay, by the mechanic at the end of a 25 centimeter range to be loosen the nut. This amount of the lever arm, or we can write D. Okay. So the angle between the axis of rotation and the force is 90 degrees. Okay. So we know that this amount is the torque. But what's the unknown quantity of this question? What's minimum force? Minimum force must be exerted. This is a known part of the question. We have to find force that must be knit or to loosen a nut on the wheel of a car. Okay. At the beginnings, we have to separate between known and unknown part of the question. Torque we have equals to 50 Newton/meter. So the D equals to 25 centimeter. But we have to convert this distance from centimeter to meter, and equals to 0.25 meter. Or we can write 25 times 10 power minus 2 meter. Find what's the minimum force. We have to find force. Okay. How we can find force according to the main rule of torque? Okay. Torque equals to Fd, okay, sine theta. This is a main rule of torque. But we want to find force equals to torque over d sine theta. Okay. D we have equals to 50 Newton/meter. D we have 0.25 times sine 90, we know that equals to 1. 50 times 0.25 equals to what? 50 times or divide 25 equals to 200. What is the main unit of force? Is Newton. Okay, so we can decide A 20 Newton, it's wrong. B 200, C 150, D 133.3 Newton. But the correct answer is selection B 200 Newton. Thank you. Hello dear students, now I will solve question 2. It's about our chapter 2. The object is completely in equilibrium. The object is completely in equilibrium if one of the following is correct. Complete equilibrium, we know that we have three types of equilibrium. Translational equilibrium, okay? And rotational equilibrium and complete equilibrium. So in some time it's called total equilibrium. The main condition to happen, to take place to equilibrium of a translational must be the summation of force acted of the object equal to 0. But about rotational condition, about rotational equilibrium, summation of torque must be equal to 0. But about total equilibrium must be summation of torque acted on the object and the summation or net force that acted on the object must be equal to 0. But about this question, we have to detect the condition to happen completely equilibrium. A. Summation of force is larger than 0. It's wrong or it's incorrect. B. Summation of torque is smaller than 0. It's incorrect. Summation of F is larger than 0 and summation of torque equal to 0. D. Summation of force equal to 0 and summation of torque equals to 0. Then we can decide or we can select. The selection D or the option D is correct. Summation of force equal to 0 and summation of torque equal to 0. Then we can decide. Select option D. Thank you. Okay, dear students, now I will solve question 3 is about chapter 2. A meter stick is supported at its 50 centimeter mark. Okay, this question is about equilibrium. At the beginning, you have to draw the figure of a meter stick. We have a meter stick. It means 1 meter. 1 meter equals to 100 centimeter. Okay. A meter stick is supported at its 50 centimeter mark. Centimeter mark, this is 0 mark, 10 mark, okay, 20, 30 mark, 40 mark, middle of the stick is 50 mark, 60 mark, 70, 80, 90, 100 centimeter. Supported at point 50 centimeter mark. It means the stick is supported by point of 50 centimeter mark with according or with by the rod or string. After that, by a vertical string, this string have tension force. Okay. Attached to the ceiling, a 1.2 kilogram mass hangs from 70 centimeter mark. We have a mass of 1.2 kilogram, okay, mass is supported or hangs, okay, supported or hangs at 70 centimeter mark. As 6 kilogram mass is attached vertically from 30 centimeter mark. We have another mass that support or hangs at with mass with 6 kilogram at point 30 centimeter mark. Okay. Mark on the meter stick. Find the location of the point at the 0.4 kilogram mass should be attached to the stick to keep a state of rotational and translational equilibrium. We have another mass at the right side. 1.2 is larger than 0.6 kilogram. Okay, what mass should be hangs to keep the condition of translational and equilibrium condition? Okay. At the beginning, we have to, or according to the condition of the rotational motion or rotational condition, summation of torque must be equals to 0. This means that the torques that acted on the stick to the direction of counterclockwise must be equal to the torque that act to the same stick to the same direction of what? Of clockwise. Okay. This point is the axis of rotation. So the determination of axis of rotation our point of axis of rotation, it's very important. The axis of rotation to this question is 50 centimeter mark. Okay, this torque to the same direction of clockwise. This is total torque to the same clockwise direction. Or counterclockwise, this counterclockwise. This number at 6 kilogram mass, 0.6. 0. What? 0.6. Okay? 0.6. 0.6 kilogram is M3. Okay. To the counterclockwise, 0.6 times. What's the distance between this point to the axis of rotation is 20 centimeter plus M we haven't times what's the distance, okay, what's the distance between the axis of rotation and this mass because of at the point that a 0.4 kilogram mass should be attached. This mass is, okay, 0.4 kilogram. 0.4 kilogram. 0.4 kilogram times D. D we haven't. We have to determine or calculate or find it. Okay. 1.2 kilogram times what's the distance between the 70 mark and 50 mark is 20 centimeter. Okay, by calculation we get D equals to 30 centimeter, but this amount is the distance, okay, is the distance between the mass of 0.4 kilogram from the axis of rotation, but we have to find the mark. The mark is 20 centimeter. 20 centimeter. 30 centimeter is the distance between the third mass, okay, with the axis of rotation. Okay, but what is the mark? Because the question, stick to keep a station. Find should be attached to the translation and equilibrium, okay, condition. At mark 20 centimeter is different than distance. At mark 30 centimeter, but the selection A is correct because the distance is 30 centimeter from the axis of rotation. This means that the distance between the M3 and axis of rotation is 30 centimeter. But at the same time, we can say the mass of 0.4 kilogram must be hangs at point 20 centimeter. Thank you. Dear students, now I will solve question 4 is about the chapter 2. The combination of an applied force and frictional force produces a constant torque of 34 Newton meter of what? This number is very, very important. This is a net torque, okay? This is a net torque equals to 34 Newton dot meter, or we can say this torque will produce as a result between the applied force, okay, minus friction force equals to 34 Newton dot meter. Okay. On a wheel rotating about axis, fixed axis, the applied force acts for 5 seconds. The phase time is 5 seconds. So the angular speed is changed from 0 to 10 rad per second. And this time, initial omega equals to 0. So it increases to omega final equals to what? 10 rad per second. Okay, the applied force is then removed. We know that when the force is removed, the motion of the wheel starts or begins to decrease, to slowing down. Will increases from one time. And the wheel comes to rest. Comes to rest means that omega final equals to 0. So the omega initial equals to 10 rad per second. In interval time 50 centimeter, delta t equals to 50 seconds. Okay. What is the net torque, or what is the torque that applied on the wheel? We have to find torque that produced by the applied force. Okay, we know that torque applied equals to 34 minus, okay, torque that produces by friction force. Okay, at the beginning we have to find moment of inertia of the wheel. With according to the Newton's second law, tau equals to I alpha. Do you understand? Okay. So I equals to tau over alpha. Net tau we have 34. Divide by what? Alpha we haven't, but we can't find it. Alpha equals to final omega minus initial over t. We can find it. Equals to, okay, 10 minus 0, 10. Divide by 5 equals to 2. 34 by 2 equals to 17. What's the main unit of I? Kilogram dot meter power 2. Now I can find what? Moment of inertia of the object. After that, we have to find tau of subfriction equals to I alpha. But we have to find alpha when the wheel begins to slowing down. Omega final equals to 0 minus 10 divided by 50. Okay? We get to that. 0 minus 10 equals to 10. Divide by 50, okay, equals to 0.2. 0.2 times 17 equals to what? Newton dot meter. I again for you. I we have equals to 70. 0 minus 10 equals to 10 minus 10 divided by 50 equals to 0.2 times 70 equals to 3.4. Okay, equals to 3.4. 3.4, but in negative, equals to minus 3.2. 0.2, 3.4, sorry. After that, we can find T application equals to 34 plus, okay, 3.4. 73.4 Newton, okay, dot meter. The correct answer is 37.4 Newton dot meter. This is amount of torque due to the applied force. Then we can write B equals to 37.4 Newton dot meter. B equals to minus 3.4. It's wrong. C, it's wrong. D, it's wrong. The correct answer is selection or option A. Thank you. Hello dear students, now I will solve question 5 is about our chapter 2. This question is a ministerial question to the year 2025 first round. Question 5. The product of a rotating object's moment of inertia and angular displacement about the same axis. The product of rotating object's moment of inertia, okay? Object's moment of inertia, it means I, and the angular speed of the same object about axis is called dash. This is a definition of angular momentum. Why? Because we know that angular momentum will produce as product between the moment of inertia of the object and the angular speed of the same object about the same axis. This is a definition of angular momentum. A. Torque, it's correct, incorrect. Rotational kinetic energy, it's incorrect. C. Angular momentum, it is correct. So we can select or we can say the correct answer is C, angular momentum, because this is a definition of angular momentum. So dear students, definitions of physics for the 12th grade is very important. Because of this is definition of angular speed, you have to care to all definitions of physics to the 12th grade. Thank you. Hello dear students, Mr. Ismail. Now I will solve another question for you. It's about of chapter 2 to the year 2025 and first round. Question 6. A solid sphere rolls along a horizontal surface at a constant linear speed without slipping. Yes, without slipping, it means without sleeping, okay? Without sleeping. Without sleeping, it means that the object have rotational motion and translational motion. Okay. What's the ratio between the rotational kinetic energy, okay, rotational kinetic energy about the center of the sphere to its total kinetic energy? We have to find the ratio between the total, between the rotational kinetic energy to the total kinetic energy of the same object. But our object is about of what? Solid sphere. Okay. Ratio is very, very important. The ratio between the rotational kinetic energy to the total kinetic energy. Okay, we have to find this ratio. Okay, rotational kinetic energy, we know that equals to the 1/2 mv power 2. So the total kinetic energy includes rotation and what? Translational kinetic energy. 1/2 mv power 2 plus 1/2 I omega square. Okay. But rotational kinetic energy, sorry, equals to what? Equals to I times omega power 2. Okay. After that, 1/2 it's constant, okay? But you have to convert, or you have to write the main rule of moment of inertia of the solid sphere equals to 2/5 mr square. So omega square equals to v power 2 over r power 2. 1/2 we have to rewrite it. 1/2 it's constant. So I, we have to write moment of inertia of the solid sphere equals to 2/5, okay, mr square. So that omega square, so the omega square over r square equals to square. This variable is cancelled. 2 with 2, 2 with 2. The amount of the numerator is what? 1 over 5 equals to 0.2. 1 over 5 equals to 0.2. 0.2 plus 0.5 equals to 0.7. So that 0.2 divided by 0.7 equals to what? 2 over 5. The correct answer is what? 2 over 7. We know that option A is writing 2 over 7. It's correct. B is not correct. C is not correct. D is not correct. Or we can say it's incorrect. The correct answer is option A, 2 over 5. Thank you.